Okay, so chapter 5, section 1. So 5.1 is verifying trig identities, in which we are going to take an expression and simplify it by replacing what it equals in a different way. So your reference slide for this whole chapter is this, well, not this whole chapter, but the first couple of sections is this piece of information right here. You must know everything on this piece of paper or on this slide, okay? I'm not going to give you a reference sheet. The top ones, hopefully we know and are pretty familiar with the reciprocal identities, like cosecant gets replaced with 1 over sine, secant with 1 over cosine, cotangent with 1 over tangent. And then tangent can be 1 over cotangent, but it can also be sine over cosine, and cotangent can be cosine over sine. Hopefully these are nice and familiar, okay? I would say we've gone over the even and odd functions, which is the third thing there, where sine of negative x equals negative sine of x, and tangent negative x equals negative tangent of x, but the one that doesn't change is cosine. So the cosine of negative x becomes a positive cosine of x, so that sign would not change based on the negative angle. And then the cofunctions we talked about last chapter as well. This is our complementary angles and the functions that would equal each other. So the cofunction of sine pi over 2 minus u is cosine. The difference here is you don't really have to be finding the value of an angle like we did the first time around. You can literally just see that if it says pi over 2 minus an angle, that means replace it with its cofunction. So sine of that would get replaced with cosine. Tangent of that would get replaced with cotangent. Secant with cosecant. And then the flip-flops. Sine, or cosine would get, cosine of pi over 2 minus u would get replaced with sine, cotangent with tangent, and cosecant with secant. And then what we haven't talked about yet this year, but I know is covered in Algebra 2, is the Pythagorean identities. So the first and most basic one is that sine squared plus cosine squared equals 1. If I actually took a right triangle, let's just say I used my 3, 4, 5 triangle, and I put theta in the corner, and I said to find the sine of theta, it would be 3/5, and the cosine of theta would be 4/5. The Pythagorean identity comes from the fact that if I were to take and square sine squared plus cosine squared, I should get 1. So if I actually work that out, I'd get 9 over 25 plus 16 over 25, which is 25 over 25, which is 1. So that's the backing of it. You don't have to be able to describe it to me. You just have to know it. Sine squared plus cosine squared is 1. That's the first one. The next one is tangent squared plus 1 equals secant squared. And the last one is 1 plus cotangent squared equals cosecant squared. So the two C reciprocal functions go together, and then the T and the S go together. You can either choose to memorize those, or I'll show you how to derive them. If you just know the first one, so if I know sine squared plus cosine squared equals 1, and it's really sine squared x plus cosine squared x. There's a variable there. Okay? If I take each of those and divide them by sine squared, I get sine squared divided by sine squared, which is what? 1. I get cosine squared divided by sine squared, which is what? Cotangent, right? Cotangent squared. And I get 1 divided by sine squared, which is cosecant squared. That's okay. It's Monday morning. So that gives me the last one on the list, okay? If I take the same original function and this time divide everything by cosine squared, then I get sine squared divided by cosine squared, which is what? Tangent squared. I get cosine divided by cosine, which is 1. And I get 1 divided by cosine squared, which is secant squared. And that gives me the second one. So if you want to memorize all three, go for it. Okay? That's one way to do it. The other way is if you forget or you're unsure, then you can derive it. Just know that first one, that sine and cosine one, and then divide everything by sine to get this, the last one, divide everything by cosine to get the second one. Yep.
For the top one, do you divide it by sine squared or sine squared?
It's technically sine squared x. Yeah, every time is technically like a sine squared and a variable. So this time it could be x, it could be t, it could be theta, it could be anything like that. Yeah. So those would have been x's. Yeah, like that. All right, so questions on any of the piece of information you have to know. So again, that whole reference sheet is something you need to memorize. Okay, write it out as many times as you need to memorize it. I don't care. Just make sure you know it. And then you'll start to see the kind of baby step our way into it. So this one says use the given values to find the values of the 6 trig functions. So we're back to if I gave you the sine function or the cosine function, something like that, and it's a ratio that's not on my unit circle. What do I do with those? Draw a triangle from it. So I could start with the first one, but this time they give me the information in a different way. What is sine of pi over 2 minus x? Cosine of x. So this is a co-function. There should be an x here. Equals negative 5/13. So based on the first piece of information, I can set up a triangle. I can put x in the corner. And the cosine is the adjacent over the hypotenuse. And then I could know my triple, right, which is 5, 12, 13. I can fill in that last side. Or I can use the information that they give me here, which is 5 over 13. Except that there's something there that tells me more information, which is what? That's negative. Which part of that's going to be negative? The 5. Remember the radius, which would be the hypotenuse, is never going to be negative, which means that the opposite side has to have the negative 5. So without that second piece of information, I would have assumed everything's positive, and I would have been wrong. They needed to give it to you with that second piece of information. So now I'm going to go through. I already know sine. I already know cosine, which means the next thing I need to find is tangent, which is opposite over adjacent. And then I need to find cosecant, which is negative 13 over 5. And then I need to find secant, which is 13 over 12. God bless you. And then I need to find cotangent, which is negative 12 over 5. So first function, second function, third, fourth, fifth, and sixth. They're not always going to be triples, okay? Sometimes you're going to have to find that third side using your Pythagorean theorem, and sometimes it will be a square root, which you want to just make sure is simplified as well.
Instead of drawing the triangle, can you find tangent by doing sine cosine?
Yep. So you could have also taken the negative 5/13 and put it over 12/13 and done keep, change, flip, and you would have gotten the same thing. All right, and then we get into a bunch of problems like this, which the directions will simply say simplify the given expression. Okay, this is where it gets a little bit trickier because you have to figure out what to do, and it's different every time. There's not a step-by-step process for these. Okay, so if I were to say cosine of x times secant of x minus cosine, what's your first instinct tell you to do? Distribute the cosine in, okay, like I would normally do with a regular expression. So I get cosine of x times secant of x minus cosine of x times cosine of x. Now, typically what I would do is look at anything that's not a cosine or sine and see if I could replace it with its reciprocal function. So what's the reciprocal function of secant? 1 over cosine. What is cosine times cosine? Cosine squared x. So the trig function gets squared. The x does not get squared. Nope. So what's cosine times 1 over cosine? This is 1. What's 1 minus cosine? Sine. So if you go back to your your Pythagorean identities, we had sine squared x plus cosine squared x equals 1. And so to get this cosine on the side with the 1, I would have subtracted it from the left and the right, and I would get 1 minus cosine equals sine squared x, which is as simplified as it gets. Okay, this one tells you to factor the trig expression. So I've got 3 terms there. It's a trinomial, okay? If I wanted to replace, let's say that a is sine of x, This becomes 3a squared minus 5a minus 2. And then it might be a little bit easier to factor, but then I've just got to put the sign in at the end. So here I can either do trial and error, or I can multiply the first times the last. Trial and error would tell me that the first terms have to be 3a and a. And the last terms have to be a combination of -2 and 1, or 1 and -2. So if I did -2 first, +1, and then multiply the outer and the inner, I get 3a minus 2a, which does not give me 5a. So then I have to try a different combination. Say 1 and 2. This time I get 6a minus 1a, which is 5a, but not -5a, which tells me all I have to do is switch those signs in between. This becomes positive, that's negative, and now I have -6a plus a, which is -5a. So that's the combination that works. And then it just wants me to factor it, so the only thing I have to do is put that sign back in. So we took the sign out, replaced it with a variable like a, so that we could simplify our process, but we have to make sure to plug it back in at the end. So like when we get to 5.3, it would then say solve that, and we'd be working backwards with our unit circle to solve it. But for right now, we're just factoring it, so you want to leave it the way that it is. Questions on that one? God bless you. All right, 4 says perform the multiplication and then use the fundamental identities to simplify. So expand that and FOIL it and see what you get. Start there. All right, so because it's squared, I can't distribute in the squared, which one of you will do on the test, and that's wrong, so don't do that. Okay, we have to expand and FOIL, so it means sine x plus cosine x times sine x plus cosine x. And then when I multiply these out, remember the trig function gets squared but not the x, so that becomes sine squared x plus sine x cosine x. And then the inner 2 plus, and I'm just going to keep it in the same order so I know to simplify it, sine x plus cosine x. And the last one, cosine times cosine, so cosine squared x. So that's first step is expand it, FOIL it. Now I can combine like terms, sine squared x plus 2 sine x cosine x, and you could have had 2 sine or 2 cosine sine x, it's fine, same thing, plus cosine squared x. Typically, you'll never leave something with like 3 terms. Like there's something there that you can simplify. You just have to find it. I can't replace sine or cosine in the middle to like cancel out a reciprocal function. That's not gonna cancel. But what can I do with sine squared and cosine squared? Good. Add them together and make them 1. So sine squared plus cosine squared is 1, which means I can rewrite this as 1 plus 2 sine of x cosine of x. And again, I'm not gonna be able to break sine or cosine down or split them up, which means that's as simplified as it gets. And again, your answer could have been 1 plus 2 cosine x sine x, same answer, or 2 sine x cosine x plus 1, 2 cosine x sine x plus 1. Order there doesn't matter. Okay. Questions on that one? So kind of told you what to do, but at some point it's just going to say simplify. And you've got to figure out what you're supposed to do each time. All right. Example 5. Use, again, this is like where the directions will just come into play. Use fundamental identities to simplify the expressions. All right, so I wrote the Pythagorean identities up at the top. Try to avoid being as lazy as possible and just pulling in a screenshot and try to make yourself at least write that stuff out a couple of times so you know that you know it. So A, cotangent of theta times secant of theta. What could I do there? And I'm going to tell you right now that there's more than one way to do these, so sometimes you might get something different from your friend. It doesn't mean that it's wrong. So what's something I could replace?
You could replace cotangent with cosine theta over sine theta.
Okay.
And then change secant into 1 over cosine
Okay.
theta. And then the cosine cancel out, and then you get 1 over sine, which is the cosecant.
Good. So one thing I would say is you're never going to want to leave something as a reciprocal function. So if you saw it and you're like, well, it's sine is simpler than cosecant, but one term is simpler than the fraction, right? So I would always want to bring that to the top, and when I do, that's cosecant. Good job. All right, B, 1 minus sine squared over cosecant squared minus 1. What is 1 minus cosine, or minus sine squared?
I did cosine squared of x.
Good, so cosine squared of x. And then what's cosecant minus 1? Cotangent. And I would say be really careful because sometimes you're going to see that as like just cosecant, not cosecant squared. And everybody assumes as long as it's got a minus 1 or a plus 1, that's a Pythagorean identity, which is not always the case, right? These are both squared, which is why they are Pythagorean identities, but it's not always the case. All right, so is that as simple as it gets? No. What can I do with cotangent?
Sine squared over sine squared.
So I could do cosine squared over sine squared. And then I've got a fraction within a fraction, so I can do keep, change, flip. Sine squared over cosine squared. So this is gone. And then cosines cancel out, and I end up with just sine squared x.
But you weren't able to do it different ways than that.
Yep.
Okay.
So what did you do?
I changed cosecant into 1 over sine squared minus 1, and then I did sine squared minus sine squared. Canceled the sines, so you have 1 over sine squared over sine squared.
Yeah, and then flipped
Switched
it.
cosine squared.
It works.
Over cosine squared.
Yep, it works. And I would say that there's a couple of tricks like you could use to help you like a little bit. So like when I get something like this, like cosine squared of x over cotangent squared of x, as long as they are in one function form, so I can't do this with a 1 minus cotangent squared, but if it is just a single term by itself, then I can just move it to the top, and when I move it from the top to the bottom or the bottom to the top, it becomes its reciprocal function. So you can also take cotangent squared, move it to the top. What's the reciprocal function of cotangent squared? Tangent squared. And then I could have done cosine squared x times sine squared x over cosine squared x. And those cancel, and I get sine squared x. So you'll, again, tons of different ways. So like Amanda took hers, made those two separate terms in the top into one fraction, bottom into one fraction, and then keep, change, flip. That works too. Okay, as long as your answer is in simplest form, the steps it takes to get there might be different. And this is one of those tests in which you're going to have to show me a lot of work because your work proves your answer, especially when we get into the next section. Like it's going to say, make this equal sine squared of x. And so I know that you know what it's supposed to say. Your work is what gets you the credit for it. Okay. Questions on either of those? God bless you. Okay, last one. So rewrite the expression so that it's not in fractional form. So it tells you specifically get rid of the fraction, but hopefully even if it just said to simplify, you would know that you're probably not leaving it as a fraction. So this is one of those that I was telling you before, that people will look at that bottom and say, oh, that's Pythagorean identity. 1 minus cosine is sine. Is that true? No, it has to be squared. So I'm going to let... All right, who can tell me what's the first step that you did? Okay, so you multiplied by 1 plus cosine in the top and the bottom. So the top, did you distribute that out? Sine squared plus sine squared times cosine over 1 minus cosine squared, right?
Yeah.
Okay, then what?
And then I simplified the denominator into just sine squared y.
Okay, so sine squared y plus sine.
And I would put sine squared y over like each item individually.
Okay, then split it. Okay, and then canceled, yeah?
Yeah.
And then got 1 plus cosine y. That works. Anybody do it differently? Emily?
Why is it 1 plus cosine?
Because it's sine squared y over sine squared y. So when those cancel, they leave you with 1. Nobody did it differently?
I
Yeah?
did it differently, but I don't think it's correct.
So let's walk through the process. I'll tell you if it's wrong. Nobody's ever died by trying.
I literally just did sine squared y is equal to 1 minus cosine squared y.
That's how I would have done it. And then this, yes.
Yeah, and then you just take off the square.
So that's where you're wrong. Okay, so good to first step, but I can't just say, okay, well that cosine cancels that cosine, right? That's an expression. That's like saying 1 minus x squared over 1 minus x. Can you cancel just the x's? No, it's a package deal. But what can I do with 1 minus cosine squared? Think the other way around. Is 1 a perfect square? Is cosine squared a perfect square? Is that the difference of them? Yes? So you can factor it. Good. 1 plus cosine, 1 minus cosine. And then I can cancel through my 1 minus cosines, and I get 1 plus cosine. So that's one of those where your answer, you would have gotten lucky because your answer, but you would have lost credit on the work. So just be careful. Because especially sections 1 and 2, I'm going to look at your work. Anybody do it differently than that? All right. Questions overall? So for me, trig identities are one of the hardest things to teach because I can't tell you this is step 1, this is step 2, this is step 3. All I can tell you is you got to try. You got to try, start replacing things, try to see. And sometimes you might get to a dead end and be like, oh, that's totally wrong. Let me try it a different way. And you got to try it a different way. Okay? And I think 5-2 is even easier than 5-1 because 5-2 gives you an end goal. You know what it's supposed to look like at the end. You just have to get to the steps to get you there. So your assignment's already published. You can work on it. Okay?